All right, so this video is going to cover rational exponents. Or radical. I said I even have radical exponents. um anyway, it deals with radicals, not rational exponents. I don't know. I wrote it wrong on my notes. So let's look at what I mean. So if I have something like a to the 1 over n, that is a fraction on the exponent. So that's the idea of a radical, or I guess maybe it is called a rational exponent. Anyway, a fractional exponent is what I usually call this section, but then what we do is we take the denominator, and that's going to become what is your root on your square root, and a, or whatever's underneath, will go to the power of the numerator. So sometimes if it's a 1, right, that wouldn't affect it. So if I have like a half as my exponent, that's just asking for the square root. If I have a third, it's asking for the third root. So here is an example of something that we could have. What if I have 4 to the 1/2? What am I really asking when I have the 1/2? Well, I'm saying, well, what is the root of 2 when you have 4 to the first power? 4 to the first power is just 4. So what is the square root of 4? Well, 2 squared is 4. So we can undo that square with that root and get a 2. Okay? And we could step it up a little, and we could do, let me do a harder one. I gotta cheat and use my calculator to do a little bit harder one. What is, I think I'm right, but I don't want to be wrong. Yeah. What if I did 5, oh, what am I thinking? Now I'm giving away the answer. 125 to the 1/3 power. I was like, why am I writing 5? It's my sickness. Okay, so if I have a third, that's like saying, okay, you have a third root of 125 to the first power, or just 125. So what's the third root of 125? Well, what times itself 3 times gives you 125? That's going to be 5. Okay, and you know, it might be helpful if you make yourself a list of third roots. So you go 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 to the third is 64, 5 to the third is 125, 6 to the third is like 216. Anyway, make a list of those so that you have them really handy. Excel's a great place to make those. What if I made it a little different? What if I have ooh, I don't like this example. Let's just do this one. What if I have 81 to the 3/2 power? What is that saying? Well, 81 to the 3/2 power is telling you that you really have a root of 2, but you're taking 81 to the third power. So sometimes, just so you know, they might write this same thing like this. I don't like to write it that way because people don't simplify it right. So my math lab likes to write the third power out here. Just know that this is the same thing as this notation, although it looks a little strange because they put it over here. I don't know. It's the first time I've seen it. It's in the Pearson products. But what we want to do is we want to take 81 to the third. Well, I don't know that one off the top of my head, so I'm going to do that on my calculator. And I get a very big number. So I'm going to get the square root of 531,441. Then I can put that in my calculator. So square root of that big old number is going to give me 729. So you got to get good at your calculator for these, because there's no way you would have thought of, yeah, 729 squared is 531,441. So get good at your calculator and how you use that for those kind of notations. Let's look at one that makes you look at a negative Um, like, here's a hard one. Well, I find them all a little bit hard, but that's all right. So I have the fraction of 64 over 125, and it's all to the power of negative 2/3. So let's rewrite that. What's the negative do? The negative flips it. So I can get rid of the negative right off the bat and just say, okay, if I flip the fraction, I've gotten rid of the negative. Now let's take care of the 2/3 power. So that would tell us we want a radical to the third power, and we want each thing squared underneath. Okay, and I broke it up, but either way. So the square's on top, so you're going to square each thing, and then the third root goes here. So then I just take out my calculator and I have to figure out the square. So I'm going to have the third root of 15625 over 4096. Look at each of those separately. Take the third root of the top and you're going to get 25. Take the third root of the bottom and you get 16. So it's simplified pretty. And that's how my process and my brain goes through. You might see it a little different when you do your problems or think of it differently. Okay. This is my 5th question. All right, so what if I have something like square root of x to the 5th and the square root of x to the 8th? If you have something like this and it says write it with a fractional exponent, we're going the opposite direction basically. So what we want to think of this is this one here on the top is going to become x to the 5 over 2, right? 5 over, this is like a 2 when we don't write it. So this would become a 5 over 2, 5 from here, 2 from here, over x to the 8 halves. All right, then it is a exponent division problem, which is subtract. So we can subtract this one from this one. So basically you just take 5 halves minus 8 halves. That's going to give you negative 3 halves. So you have x to the negative 3 halves. Well, to get rid of the negative, you can put it in the denominator. So you basically end up subtracting them and you keep it in the denominator to keep from having a negative exponent. And that'd be your final answer. Kind of ugly. And it takes a lot of thought process to get through these. You have to write them as a fraction, and then you have to think about what are the rules with exponents. Well, with division, it happens to be subtract the exponents. All right, let's get another one. This one likes to show up on the final exam, or similar one. All right, so this one, we start with the middle, and I can think of this as m to the 1st to the 3rd. So I'm going to keep the outside out here, and I'm going to write this as m to the 1/3 power. Then what is this outside one doing? Well, it is like a 4th, right? Because you don't have another exponent. So one way to think of that is you're going to have an m to the 3rd, and then the outside is going to be a 4th. Then what's the rule that we can do with these when it's an exponent to an exponent is you times them. So 1 times 1 is 1, 3 times 4 is 12. So you get a m to the 12th. Okay, kind of tricky. What if I then have my last example? What if I have something like this? I actually cannot simplify this because they have a different root. That's what we've always said, is you can't simplify them. This would be your answer. You can't do anything. Let's write it as an exponent. This would be a 3rd times x to the 1/2. What is the rule when you're timesing that you can do with the exponents? Well, you can add them. So we look at 1/3 plus 1/2. Get your common denominator. I'd use 6 times this one by 2, 2, 6, times this one by 3, and you get 3/6. 2 plus 3 is 5/6. So we can simplify this as x to the 5/6, and we're done. Let's see. So sometimes the directions will tell you to write with positive exponents and no radical. Sometimes they'll tell you to write with the radical. So you kind of have to be able to go back and forth. Right? And that's going to end my examples for this one.